listen to it twice. Okay, so 11/3. So the square root of 3 squared is just what, class? 3. You don't have to say radical 9 and 3. Whenever you multiply a radical by itself, it undoes it, and it's just the radicand. So if I have x plus 1 squared, what would that be? X plus 1. And if I have radical 2x minus 5 squared, I would just get 2x minus 5. It undoes it. Do you guys remember back when we did x to the 1/2?
Yeah, that was torture.
Yeah, like 3 days, like
Yeah,
3 weeks ago, we would have something like 9 to the 1/2. So on that, we rewrote that as 3 squared to the 1/2. It was in our exponent chapter, so it was just like 3. So this equals 3. Now 1/2 is really the square root of 9. So for you to see it again. Now, if you are solving a radical equation, first of all, the first thing you do is always isolate the radical. And then you square both sides. The second step is square both sides. And I'm going to explain why in a moment. Sides. So on here, let me unplug this. On here, first of all, is a radical all by itself? Jordan, is a radical all by itself? No, so I'm going to have to add 3. And you have the radical x equals 7. Now I'm going to square both sides. Because when I square a radical, what are you just going to get? The radicand. And what's the radicand? X. And the answer is 49. There is your answer. I want to see this work, and some of you would just go guess and check, but that's not going to fly anymore. You have to show the algebra work. To check your answer, you substitute it back into the original problem. Radical 49 minus 3 equals 7. 7 minus 3 equals 4. 4 equals 4. It checks. Now, why do you square things? Think back of what we have done in the past. When we were in our radical chapter, and we had x squared equals 4. To solve that, what method did I use? I used the square root. And I got positive -3, right? Okay, so now what if I have the square root of x equals 4? To undo that, here you had, remember the original problem was this, you took the square root. Now I have the square root, so what do you think you're going to do first? You would square it. And you would get x equals 16. So here you went from quadratic and you took the square root. Here you had a squared, I want to say, squared x. And you take the square root. Here we have a square root, and we square both sides. You're undoing it. Okay? So on this one, Michael, is the square root by itself? What else is on the same side as the square root sign? Is the -3 outside the radical? No, it's under it. So this is part of the radicand. The radicand is x minus 3. Here the radicand was x. Looks very similar but different process. So on this one, you can square both sides right away. Do you see the difference? So you would get, when you square this, what would I get? 3 equals 16. Add 3, your answer is 19. Pretty easy, right? If I check the answer, you have 19 minus 3 equals 4. Square root of 16 does equal 4. Remember, when we're taking a square root of a number, the radical of a number, you're looking for the principal positive root. Radical 9 is 3, not negative 3. Radical 25 is 5. Okay? So on this one, Michael, just to make sure you understand, what would you have to do on this one first? You'd square it against the radical by itself? What's the radicand of the radical? What's the number under? Just the x. Here it was the x minus 3. So is the radical term by itself? What? Is that by itself on this side of the equality sign? It is. Don't I have a plus 7? So how am I going to get rid of the plus 7? Subtract 7. Hold on, I see your hand up there. I'll answer in a second. And then what would I do on both sides? You would square it. And you would get x equals 25. The square root of 25 plus 7 equals 12. 5 plus 7 equals 12. So it works. I'm not quite convinced, Michael. I'm not done with you. What are you going to do first on number 4? You're going to add 4. Let me ask you on number 5. What would you do first? Because the radical is by itself. Here the radicand is a, here the radicand is x minus 2. Two different processes, but they look very similar. Is everybody clear on it? Adam, you have a question? No. Okay. Would I square this one? I'd have x minus 6 equals 36. Add 2, you get x equals 38. And we now know how to solve, or how to check them. Okay, on this, we have two radicals on both sides. So what the heck? Yeah, the radical's by itself. Hazim, what do you think you're going to do to this?
Square it.
You're going to square it. And I'm going to square this side. And what would I get here on the left side?
3x minus 6.
And what would I get on the right side?
X plus 6.
Now I have to do a little bit more solving. How would I solve this, Hazim?
2x equals 4.
Okay, he would subtract x. He has 2x. And then how did you get 4?
2x equals 4.
How-
I mean, 8.
Okay, you're doing too much in your head at one time and you're making silly mistakes. You get 2x equals 8. So divide by 2, x equals 4. Let's check our answer on this. I'd have 12 minus 2. I'd have 4 plus 6. Doesn't the square root of 10 equal the square root of 10? So far, everything's worked, doesn't it? Okay, you guys try number 6.
6 easy.
Do 6, 8, and 9. Then we're going to go on to the second day because I don't want to take up the time when you have a quiz. But this will be for your lesson for Monday. This line's going through. I'm trying to. Oh. There it stopped. Try 6, 8, 9. Noah, what did you get for 6?
Well, you square it.
You square both sides?
Radical 3x. You square both of those.
Okay, and what do you get?
3x plus 4 equals 5x minus 6.
And then what would you do?
Divide by 3. Let's just subtract 3.
Subtract 3.
Get 3x.
Okay, so what do you get now?
So I get 4 equals 2x minus 6, add 6. For 10 equals 2x, x equals 5.
Doesn't work. I would have 15 plus 4 is 19. 25 minus 6 is 19. Good for us. Okay, Eric, on number 8, what would you do first? Add 5. Have to isolate it. You have radical x equals 9. Then what do? Square both sides, and what's your answer? Very good. Okay, Max, what would you do on number 9?
You would first square both sides,
Square both sides.
and then you would add
Oh,
5.
okay, so I think we have that down. Okay, now let's go to the back side. Extraneous solutions. We've seen this before. It's like a restriction. It's what you get. You might solve an equation, but when you go back and check your answer, it doesn't make it true. So even though you solve, you get an answer, but it doesn't make the original equation true, it is not a solution. That's called an extraneous solution, and you cross it off. So let's look at this. Okay, number 1. Notice how is this equation different than the other ones that we've been doing? It equals x. So notice what happens. The radical is still by itself. I'm going to square both sides. And you would get x squared. And on the right side, what would I have, class? So guess what we're at? We're at quadratic equations again. How do we solve quadratic equations? I told you you had to get this down. You get it equal to 0. I would factor it by using the diamond. I'd have x minus 3, x plus 2. By the zero product property, my answer would be 3 or negative 2. Now remember the original equation, when you were checking them, you are going to substitute it into the original problem. Syra.
Wait, why is it x squared and not negative x squared? Like when you substitute it?
When I substitute it in,
Yeah.
you square it.
No, in the next step. Like
Right here, I brought this over to this side.
Oh.
Okay. Whenever I use the diamond, Syra, I always want a to be positive. So I move the other two terms over. Farnham. Because you're going to use the diamond. Okay, so are we all here? Okay, now, looking at this, if I plug in 3 into the original, not into here, has to be in the original. Everybody hear that? Max, you hear that? So now you would plug in 3. I would have 3 equals the square root of 9. 3 does equal 3, so it checks. So yes, that's a solution. If I plug in negative 2, I'd have negative 2 equals the square root of 4. What does the square root of 4 equal?
2.
So this is extraneous. This is your only solution. Now, does anybody see a little bit of a shortcut?
I do.
Jake,
Though since it's the square root, the number can't be negative.
if you take the square root of, you can't have a square root of a negative number. So this can never equal a negative number. And if you plug in negative 2, you're saying the square root of something equals negative 2. So you know, just by looking there, whoa, that wouldn't work. How about that? Okay, let's look at number 2. What would I have to do first on this? Annika, what would I do first?
Is it square both sides?
Is that what everyone, Armand?
You subtract 6.
You have to get the radical by itself. That's what we were working so hard with Michael. You have radical 2x. I'm going to come back to you, Annika. Does anybody see something right now?
Yeah.
Can a radical equal a negative number?
No.
No. So what do you think your answer is going to be?
No solution.
No solution. If you square it, let's go through it. Let's say we didn't recognize that little shortcut, Jake's shortcut, we'll call it. And you divide by 2, you would get 2. I went through, I solved it, but when I substitute it back into the original equation, I would have the square root of 4 plus 6 equals 4. Does 2 plus 6 equal 4? I don't think so. There's no other solution, so the answer is no solution. Okay? Okay, let's look at number 4. Okay, what would I do first on this one? Dawn, what would I do first?
Square.
You would square both sides.
X equal x plus
Okay, so we have a quadratic, so we're going to end up with 2 solutions, aren't we?
Yeah.
Because it's quadratic. So now what would I have?
4. X square minus x minus 4.
And then how do you factor it?
So x minus 4 times x plus 3 equals 0.
So we have x.
Equal 4 or x equal 9. That is 3.
Okay, so can you tell me more?
Answer is x equals 4.
Why isn't this an answer?
If you put letter C and
Okay, square root can't equal a negative number. Now, does that mean that all negative answers aren't a solution? No. Because you'll see later on. Okay? Where's one? I may not have it. Okay. Annika, going back to you, what would you do first here? There you go. You get radical 3x equals negative 6. No solution by Jake's method, because you can't have a radical. If you go through and solve it and check it, it will not work anyway. Okay, I'm going to put in an extra one here. If I have 4 radical 2a equals 2 radical 6. Now, interesting, right? There's no radical that's by itself. You can't subtract, it's multiplied. What you can still do is just square both sides. Now, when I square the left side, 4 times 4 is 16, and radical 2a times radical 2a is just 2a. So I get 32a. Over here, when I square 2, you get, and radical 6 times radical 6 is 6. You would get 24. Divide by 32. A will equal 3 over 4. Reduced. Okay, we've got to go to number 7 and 8. We'll skip this one. Okay, He1, is the radical by itself? So I will square it. So I will get the radicand here. He1, what would I get on the right side? Awesome. This is x plus 1 times x plus 1. You don't just square the x and square the 1. You guys were so good at that in that lesson that we learned it. Don't forget it. Okay, now we have to get it equal to 0. So what would I have here if I subtract this? Very good. And now let's factor it. And so your answers would be what? Okay. Remember, my original equation is this. It's a little bit different than those up here. But if I plug a negative 3 into the right side, what would that make this side? Negative, right? Can it be negative? No. So even without substituting in, but if you would, you'd get this. This is extraneous. If you would check the next one, square root of 9 equals 3. Yay for us. Now what I was saying, and I don't have an example, which is bad of me, but what if you would just say assume, and you have something like x plus 5. And what if you solve it and your answers are negative 2 and 8? They aren't, just suppose. Could negative 2 work? It might, right? Because it still would be positive over here. So don't just think, oh, it's negative, I'm going to cross it off. That's not the case always. Okay, you still have to see, does it make the entire side negative? Okay? Okay, last one, number 8. Jordan, what are you going to do? Square both sides, and what would you get?
4x squared equals 14x minus 4.
And then what would you do?
You bring the 14 and the 6 to one side, and you get 4x minus 14x plus 6.
And then what would you do?
Then you would make a modified diamond.
What could I do first to make that a simpler equation?
Like this,
Yeah, take out a 2. You could just divide the whole thing by 2, and I would have 2x squared minus 7x plus 3. Smaller numbers. Okay? So you have 6 and negative 7, and what do I have to put up on top of the dashed line?
2.
And it would be what?
6 and negative 6 and
Yeah, okay. So you'd have 1 and negative 3, x minus 3 and 2x minus 1. X equals 3 and add 1, divide by 2. Let's check our answer. The 3 is easy. 6. This would be 42 minus 6 is the square root of 36. Yay, it works. Let's look at 1/2. That's pretty easy too. 1/2 times 2 is 1. 1/2 times 14 is 7, minus 6 is 1. They both work. So don't just assume because one works, the other one doesn't. Sometimes they both work. Okay, let's go over our test.